Okay, so this is a hexagon, and we're going to try to create hexagonal tiling using the wrap node. So as you can see here, this has 0.866. That's the square root of 3 divided by 2, because if you have a hexagon with a height of 1, a regular hexagon with a height of 1, then the width is going to be the square root of 3 divided by 2. It's an important number to remember, so let's click here. So where do we find this wrap? Under vector math, and then just select wrap. No, that's snap, wrap, just like that. Now let's duplicate this to add a scale. We can plug the object coordinates into here, and the only thing this does is scale. So what happens if you just plug this scale into the wrap? Nothing, because all gets set to the 0, because it's going to try to wrap between 0 and 0, which just makes everything 0. So let's maybe change this to minus 0.5 and this to 0.5. As you can see, we're now getting bands along the x-axis, which go from minus 0.5 to 0.5. And for example, we can set the height now to minus square root of 3 divided by 2. And then we can copy this, paste it, right? And then just remove the minus sign in front. So now we have the right proportions. And to create this hexagonal tiling, we're going to use the fact that if you have a hexagonal tiling, a regular hexagonal tiling, then the distance to a point is in the hexagon if it's closest to that the center of that hexagon, which is basically like Voronoi. So we're going to duplicate this one and then change this one to add, and then we're going to use this as an offset. So let's plug this into here. Now we get the same thing but offset, right? So it's shifted, and then we need to compare these two. Well, we want to mix them, so if you have node wrangler, you can press Ctrl Shift and then add a mix node. But obviously, just mixing them like this doesn't get the result we want. So we need some sort of factor, and to get the factor, we can compare the distance to the origin. So we could use the length. This would work, but a bit quicker would be to use less computationally expensive is to use the dot product, which is just the distance squared. But since it doesn't have to calculate the square root to get just the distance, it is one less operation, which makes it a bit faster. And now we just compare these two. So let's add a greater than, plug this into here. Right. And then we plug these back. So currently you can see that these the proportions aren't correct. So let's try and change, set these all to 0, and then set this to 0.5, and this to square root of 3 divided by 2. Wait, I think I'm supposed to invert it. There we go. Now we have our hexagonal tiling. I have to invert it because it's like this here. Last time I did it was I used the X. So now we can, for example, hide these like that. And let's say we want to get the indexed coordinates. No problem. The only thing we need is this add node, really, and we can set it to subtract. I think I made a video about this, how you can use the indexed, how to switch between indexed and UE coordinates. And there you go. Now we have the tiled coordinates, which gives you a unique index for each, well, not a unique index, but a unique XY coordinate set for each tile. which you can, for example, then plug into something like a white noise texture to give you a random tile. The reason it's bugging out is because the plane is on the origin, and then it doesn't. If I set this to 2D, should be less of a problem, or maybe not. But it doesn't like it when it's on the origin, because then it can't decide whether it's positive 0 or negative 0, and then it glitches out like this. So yeah, that's it.